Next, let's discuss and analyze different algorithms in a simplified setting. Let's say that there is one ad shown for each query. So this is the limit part. And let's also say that all advertisers have the same budget. And all ads are equally likely to be clicked. So basically their CTR are identical. And the value of each ad is the same. So that basically means that for each query, the bit times CTR will be the same. Now, the simplest algorithm for this setting, of course, is a greedy algorithm, where for a query, we will just pick any advertiser who has bid that query. And similar to the previous online bipartite matching problem, the comparative ratio of the greedy algorithm is at least 1/2. Now let's look at a bad scenario for the greedy algorithm. Let's say that we have two advertisers, 1 and B, and let's say that A bids on query X, B bids on both X and Y, and both of these two advertisers, they have a budget of $4, and we have the query string as X, Y, 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 Y. So we have 4X and 4Ys in the query string. Now, the worst case greedy choice would be to assign the first 4As to advertiser B. And then when the fifth query comes, since it's a Y and only B bids on this query Y, and at this time, B already exhausted its query. Therefore, at this point, there's nothing we can do. Then the total avenue here would be just $4. And of course, the optimal solution would be to assign the first 4, this 4x, to the advertiser A. And then when the fifth query comes, since it's a Y and B actually bids on Y, therefore the last 4 queries can be assigned to advertiser B. And in this case, we achieved the optimal revenue, which is $8. We can see that in this case, the comparative ratio is actually 1/2. And note that this is actually the worst case already, because the greedy algorithm is deterministic and it always rate ties in the same way here. Now we can actually improve upon the greedy algorithms using also a simple algorithm called the balance algorithm. And in the balance algorithm, for each query, we will pick the advertiser with the largest unspent budget or the largest balance. And this is how the algorithm gets its name, the balance algorithm. And the algorithm will break ties arbitrarily, but in a deterministic way. Now let's go back to the example. Let's say that again, we have two advertisers, A and B, and A bids on query X, and B bids on both X and Y. Both have budgets of $4. Now we have the same query string, 4 X's and 4 Ys. Now the balance algorithm, for example, it will start by assigning the first X to advertiser A. And after this, since this advertiser A will have a budget of $3 left, and advertiser B will have a budget of $4 left. Therefore, in the second query, the algorithm will assign this query X to advertiser B instead, since it has more unspent budget. And similarly for the third and for the fourth query, so the first 4 queries, they will assign them to AB sequentially. And when the fifth query comes, which is the Y, since at this point only B bids on Y, right, and B has still some unspent budget, therefore we can assign this fifth query Y to advertiser B. And similarly for the sixth query, we can also assign it to advertiser B. Now after this, you may have noticed that B has already exhausted his budget of $4. Therefore, when another query Y comes, there is nothing more we can do. So at this point, the total revenue we can get is actually $6. And again, the optimal revenue or the optimal solution can give us a revenue of $8. So at this point, the competitive ratio for this algorithm will be 6/8 or 3/4. And we can actually prove that in the general case, for the balance algorithm of 2 advertisers, the competitive ratio is exactly 3/4. And here's how we can prove it. Let's consider a simple case without lots of generality. Let's say that we have 2 advertisers, A1 and A2, and each of them will have a budget of B. So B is, of course, larger than or equal to 1. And let's also say that the optimal solution exhausts both advertisers' budget. And now, one key observation of balance algorithm in this simple case is that the balance algorithm must exhaust at least one advertiser's budget. Why is that? This is because if not, then we can always allocate more queries to the advertiser, to one of the advertisers. And intuitively, let's say that we have this blue part to represent the queries allocated to the advertisers A1 in the optimal solution. And we have the green part representing the queries allocated to A2 in the optimal solution. So this first part of this figure here actually represents the optimal solution. And now let's say that both advertisers have some unspent budget, as shown in this second part of the figure here. Then in this case, we can always allocate more queries, right? We can always allocate more queries to either A1 or A2 until one of the advertisers exhausts its budget. So this is intuitively why the balance algorithm must exhaust at least one of the advertisers' budget. Now, let's assume without loss of generality that the balance algorithm exhausts A2's budget, and that it allocates X queries, basically allocates X queries fewer than the optimal. And then in this case, the revenue will be 2B minus X. Visually, again, let's say that this is a figure for the optimal solution. So we have the blue part representing the queries allocated to A1 and the green part representing queries allocated to A2, right? Now, remember that in this case, the optimal revenue will be 2B. And let's assume that the balance algorithm gives the revenue 2B minus X, and which is equal, let's say that it's equal to B plus Y, as we can see in this figure here. So basically, we say that A2 has already exhausted its budget, and we also say that we assign X queries fewer than the optimal solution. So X is here. So basically, we assign only Y queries to A1 here. Then notice that the unassigned queries should be assigned to A2. Why is this? This is because if these part of this unassigned queries, if we could assign to A1, we would, since we can see that A1 still have the budget, right? Therefore, by proof of contradiction, we know that these unassigned queries should be assigned to A2 here. Now remember that our goal is to show that this Y is actually larger than or equal to B over 2. Now, we have two cases. The first case is that we have less than or equal to half of A1's queries got assigned to A2 instead. So basically, in this case, this part of A1's queries got assigned to A2. Now, this basically says that this part is smaller than B over 2, meaning that this Y is already larger than B over 2, right? And this is obviously we already achieved our goal of proving that Y is larger than or equal to B over 2. And in the second case, it would be more complicated. In the second case, we have that we have more than half of A1's queries got assigned to A2. Basically, this means that this blue part will be slightly larger than half of B. So we can see that this actually takes a larger part of this rectangle here. Then in this case, let's look at the first query of this blue part assigned to A2. Now remember that the balance algorithm will always assign a query to an advertiser with more balance, right? Therefore, the reason why the algorithm will assign this query to A2 is because at this point, A1 has already exhausted at least half of the budget B1, right? Only if this happens, then this query will be assigned to A2, right? And if this is the case, we already know that this Y is definitely gonna be larger than half of B or B over 2. So in this case, we can already know that this Y is larger than or equal to B over 2, which is our goal here. Then we already know that in both cases, Y is larger than or equal to B over 2, meaning that our revenue is always gonna be larger than or equal to B over 2 plus B, which is 3B over 2. So basically, the balance revenue will be minimum if and only if X equals to Y equals to B over 2, right? And the minimum balance revenue in this case will be 3B over 2, as we mentioned before. Then in this case, we can calculate the competitive ratio, which is the minimum balance revenue divided by the optimal revenue, which is 2B. And this gives us the competitive ratio of 3 over 4. Now, this is the case only for 2 advertisers, right? And in a general case, where we have more than 2 advertisers, the worst competitive ratio of the balance algorithm is actually 1 minus 1 over E, where E is the base for the logarithm, for the natural logarithm. And this number is approximately 0.63. And interestingly, no online algorithm can have a better competitive ratio than this one. And in the next part, we'll talk about the worst case example that gives exactly this ratio.